everybody. Welcome to our panel on critical event readiness. Before we get started, I will say there is a critical event coming up on November 3rd, so please make sure to check your voter registration so you have a say in how your communities are going to be run going forward. So also, please make sure to join us in the chat by going over to the agenda tab and clicking on this specific session so you can ask your questions to our panelists in the chat. With that, we're going to get started talking about critical event readiness. Everyday management of the grid becomes more challenging. The distribution network is becoming progressively dynamic. Complexity is increasing in the volume of data the utilities need to understand and integrate continues to grow. Utilities are improving resiliency by expanding beyond traditional centralized outage management system functions, adding mobility, damage assessment, and moving towards predictive analytics to reduce and minimize disruptions from outages. So to get started talking on this panel, I've got two great panelists that I'll let introduce themselves. Hugh, we'll start with you.
Good morning. I'm glad to be here today. My name is Hugh Avant. For the first 10 years of my career, I was working in the industry with utility companies in engineering and operations. For the last 22 years, I've been with General Electric and specializing in GIS systems for engineering design and for OMS and ADMS systems for operations, working with utilities around the world.
And John.
Great. I'm John Meary. I'm the Chief Administrative Officer at LCRA. We are a wholesale water, power, and transmission utility based in Austin, Texas, that serve the region, the kind of capital region, and then about a 600 square mile service territory that goes to the coast of Texas. As Chief Administrative Officer, I run any of the shared operational functions that are common to each of our business units: wholesale power, transmission, water, and parks. Our technology, cybersecurity, and resilience functions are part of my team. Resilience has actually been a really big focus for us over the last 6.5 years. We established it as a pretty major cross-functional effort in 2014 and have seen a lot of benefits from that. Most recently, I've served as the incident commander for LCRA for our COVID response, and I'm still serving in that role. Glad to be with you here today, Dylan and Hugh, and look forward to a great conversation.
Well, thanks for being here, gentlemen. We're happy to have you. So we can frame resiliency in lots of different ways, but you know, I've got climate on the brain based on my last panel and everything else. So let's start with weather-based events. Hugh, how have the standards for outage management and storm response changed in the last 5-ish years?
Well, I would say that the industry has been changing the tools and the processes to assist with outage and storm response aggressively for longer than the last 5 years. We've learned a lot in the last actually 20 to 30 years regarding storms and extreme weather and their impact on the network infrastructure and service reliability. And this has certainly led to an impact on the way we design and operate the grid. When I started my career, about 5 years into it was when Hurricane Andrew hit, and I was actually working at a utility company in Key West, Florida. So we were heavily impacted by that. And what we've really seen, especially in the last 5 to 10 years, is an increase in the number of these severe weather events. And a lot of companies have really invested heavily in trying to harden their feeders, especially those in areas that are prone to severe weather events. There's been a lot of investment made in converting overhead distribution feeders to underground, replacing wood poles in areas that are not converted from wood to concrete, investing in local DA schemes and teams of devices for critical infrastructure and critical customers, typically just having a minimal investment in communications infrastructure between those devices. And then recently, there's been a lot of investment in single-phase lateral reclosures and self-resetting transformer cutouts. No real communications infrastructure necessary there, but some companies are reporting up to a 70% decrease in sustained outages due to temporary faults on lines. which is really minimizing the number of truck rolls, allowing those crews and resources to be available for sustained outages across the service territory. Now, there's also been a huge influx in the amount of data that's available to systems such as outage management. Here recently with the smart grid initiatives that a lot of utilities have employed, especially around AMI systems, and being able to get the outage notifications, both the power off notifications and the power restoration notifications into their OMS systems, so that we're not having to rely on customers calling in as much to be able to predict outages, especially in during times where customers may not be active or awake, early morning hours, for example, and also to be able to determine when those customers are restored to power using those power up notifications. Certainly being able to integrate SCADA information into the OMS. So whenever there is a SCADA operation in the system, understanding where those confirmed outages are and the customers that those are impacting. And then there's been a lot of interest, not necessarily investment at this point, in mobility-based damage assessment. It's very important to be able to get this information to the back office as quickly as possible. Historically, this has really been more of a manual paper-based process where crews have been deployed with stacks of network diagrams, marking those up in the field, hours later bringing that information to the back office where it can be correlated and assimilated to really determine the extents of the physical damage. That's really important, again, to be able to prioritize the restoration, to be able to allocate the crews and the materials necessary to do the repair work. And then lastly, being able to really evolve the standalone OMS systems and SCADA systems into an integrated ADMS, which is really giving us a single system of truth for distribution operations, so that a single view into the network model where users can understand everything that's occurring in the system and be able, again, to prioritize and optimize those restoration efforts.
Hugh, actually, just one quick question. I know you said it's just something that's being talked about, not necessarily like heavily invested in at the moment, but can you just tell me a bit about what mobility-based damage assessment is? I haven't actually heard that term before.
Yeah, so again, historically during the damage assessment process, utility companies just handed out stacks of paper. Crews have gone out and patrolled the lines. Now, this is primarily during large scale weather events such as hurricanes and tornadoes and ice storms and these types of things. The mobility-based damage assessment is really taking that and digitizing that entire process, where crews have either a tablet or a mobile-based device where they are online. They're able to go out and capture this information in the field, take pictures of the damaged locations, gather specific information about the assets that are damaged. Hopefully the crews are not having to capture things like size, class, material of those particular assets, but just marking the assets that are damaged. The underlying GIS data should be populating things like size, class, material, phasing information, what customers are connected downstream of those individual devices. But because this is an online system, as soon as the user collects that information, it is available to the back office, where the computer systems will then correlate that data, do the aggregation of that data, and that data not only feeds back into other corporate systems above and beyond your operational systems. So having that interface to things like workforce management, work management systems, where the utility company can then start to stage materials based on that damage information that's been collected. So as crews are being mobilized to do the restoration and repair efforts, the materials have already been pre-staged. They can go by and pick that up, and they know the destination for where those materials need to be deployed in the field in order to do the repairs. And basically, we're talking about changing that paradigm from days of effort down to hours of effort to get those resources into the field where the repairs need to take place.
Thank you for clarifying. That sounds really interesting. John, one thing you said in your introduction that I thought was interesting, and I don't know if you intended this or not, but you talked about that you were doing the resiliency work, and part of that it sounded like was that you were also had to handle the COVID response. And I think that the resiliency and COVID are do have kind of a relationship there. So when we're talking about resiliency, we also have to talk about worker safety. So, with both dangerous weather events on the rise and also the pandemic, how is worker safety kept to the highest standards while ensuring reliability?
Sure. So great question, Dylan. And there is really a significant link between the two. So at the at the beginning of our COVID response, and as I mentioned, I've been incident commander for LCRA and might be, I'm not sure, but might be the longest running incident commander before, because I'm not sure we've ever had an event that's gone on this long. But one of the things we really laid out at the beginning of that response was that safety is our top priority, and there's two components to that. One is absolutely our direct responsibility is to make sure that we get every single one of our employees and contractors safely home at night to the people that they care about without being injured, without being hurt on the work site. We also have to remain reliable in providing especially water and electric power to our customers, because that keeps them safe. So, it's not enough for me to just keep my own employees safe. I also have to keep, hospitals running, schools running, emergency, providers having the power that they need. So we really focused the whole organization on that mission. We relied, and we were able to rely on a very well-developed resilience function that we had been working on as a top priority for really the last 6.5 years. I started at LCRA about 6.5 years ago, and so part of the answer to your question kind of goes back to then. What I noticed that was very uncomfortable at the time was LCRA was extremely effective. We were very organized, we were very reliable, and we were really optimized for the set of conditions we were facing at the time. We were not very set up, we weren't set up very well to adapt to new conditions. So if I made a sports analogy, we were a lot like a Formula One racing team where everybody knew their job, everything happened really effectively, we were really efficient. But you throw half an inch of rain on the track, or you throw a little bit of disruption, and everything needs to stop and be recalculated. We really weren't adaptable. And ultimately that comes down to being resilient. And that was not different from most utilities at that time. We really set out to say, how do we get good at change, get good at being adaptable? And we defined resilience as saying, look, we need to be able to adapt to changing conditions quickly and overcome them. So to me, that was three parts. As a learning organization, we need to be better at sensing changes in the environment more quickly at higher resolution through more automation, better data. So a better, higher resolution picture of what's going on around us. We have to make sense of that information and quickly figure out how our operations need to change, what things require change. And then once we decide how we're going to change, we have to roll that out very fast. So we have to be able to get that information quickly out to folks. So from a worker safety standpoint, we really did all three of those things. At the end of the day, it's just about becoming a learning organization at scale, just leveraging the fact that you have smart people working together who can think together. So the training materials that we've rolled out, the business processes that we've rolled out for managing presumptive positives, for case management, for contact tracing, for safety training, none of those processes existed in March. They're all new. All of the training materials, everything is new. And so it really came down to having a culture that was adaptable, that could make sense of those things, quickly develop new processes and get them in place. And there is a significant role that automation plays in that. But it doesn't substitute for that human intelligence that we need to kind of make good decisions. But automation really provides you with a big support to that process. And I'm really proud that at this point, from our benchmarking, that we've done very well at keeping our employees safe and keeping the power on.
Yeah, that I like that. I like that sort of relationship between both the automation and the agile work, corporate culture that allows you to sort of get ahead, get the processes in to get ahead of any kind of safety issues that may arise. I noticed a lot of utilities, a lot of companies in general did that in regards to the virus, which has helped in many places keep workers safe. So, Hugh, is there a way we can sort of apply that sort of planning, that sort of process to our storm response strategy, moving it a bit more from a reactive process to a proactive process? Where maybe the best places to invest to help create that agility on that side of the equation?
Well, certainly that can be done, and there's a huge trend in the industry right now to move to distribution automation. Uh, for the lack of a better term, I guess you could say it's moving towards a self-healing distribution network. And like I said previously, there has been a lot of investment made in localized distribution automation teams and schemes, specifically for critical network connections, such as hospitals and emergency services. And certainly those add a lot of value into your day-to-day operations for those types of service connections in the system. They do have some limitations to those. First of all, they don't really scale to protect large portions of a company's service territory. And the local logic really doesn't lend itself to operating in an abnormal network configuration. Most of those teams of devices operate in a single shot mode. Certainly we need those, where again, you're moving from hours of interruption down to seconds of interruption, or in some cases sub-second for those critical connections. But for the remainder of the service territory and the customers that are being served by the utility company, historically we've been looking at days and sometimes weeks of interruptions for these customers as this data is being collected in the field, as damage assessments are taking place, and then utility companies are doing their best to try to prioritize the restoration efforts. So moving to a more automated environment is certainly going to move us and move the needle to the point where we can move from days and weeks down to hours and minutes in many cases for the remainder of the service territories. So deploying distribution automation in the form of a model-based ADMS system, again, it's going to give you a single source of truth for your operational network. So it's going to have your SCADA operations completely visible and integrated within the system. It's going to bring in all of the data from your customer notifications, whether that's an AMI meter, whether it's customers who are calling in to report an outage. And it's going to present that data to the user and allow them to be able to interact with the multitude of outages that you currently have. But if we can then put in the distribution automation equipment to automatically determine where faults are occurring, to be able to isolate those faults and be able to restore service to as many customers as possible using distribution automation, we're really, again, going to move the needle to the point where we've isolated the major cause of these faults. Then we can deploy our crews to be able to go out and assess the information and do the restoration and repair work that's necessary. Now, because this is a model-based system, and what I mean by that is It's not just based on connectivity. Connectivity is really what you need in order for an OMS to be able to predict an outage location. And again, that's going to be based on customer notifications, either from meters or customers calling in. The system is going to try to predict where you may have, where the device is that's actually operated, that is the source of that particular outage. Through the injection of additional pieces of data. So looking at fault current magnitude that's coming in, that's being captured by relays within the substation, and then using power flow against this model to be able to calculate distance to fault, to be able to correlate that with fault indicators that are telemetered out in the field. Could be line sensors that companies are investing in to put on their distribution lines, and strategically placed distribution automation equipment such as SCADA enabled reclosures. A lot of times put at mid feeder points, and then also applying SCADA communications and control to tie points between feeders. The ADMS system then is able to determine where the most likely point of the fault is, and then to be able to isolate that fault safely, and then based on the power flow model, be able to reclose in the circuit breaker upstream of that faulted section, and then determine the best way to restore the downstream portion of that faulted section. Being able to look at possible locations to backfeed from. But that power flow model is going to be able to do that in an optimal and a safe way. So it's going to be able to look at the loading conditions at the time that the fault occurred. It also has the ability to look at a forward-looking type of analysis. So the systems can be configured to look 4 hours or 6 hours into the future based on loading characteristics of those particular feeders and the loads, and be able to determine how to restore those customers. To be able to do that in a way that we're not going to be introducing new violations into the system as far as voltage, or being able to introduce overload conditions or any other instability factors within the system. So these ADMS systems are going to allow companies to be able to run this in completely closed loop operation. Certainly you can run these in an advisory mode, and a lot of companies will do that during their pilot phase of the implementation. They will set the system to be in a semi-automatic mode, so that when faults occur, the system will go through and do its analysis, present to the user the recommended plan of action, where the user can then review that, and with a single click of a button in their operator console, be able to go in and implement that plan. That can then be moved into a closed loop operation where all of those actions take place automatically. We're seeing customers who are, doing this in closed loop, and the goal is to really reduce the amount of time that these customers are going to be out of service, moving things down into the range of a minute, maybe 2 minutes, certainly below what would be considered a sustained outage. The nice thing about this, again, is it's going to be able to scale. The centralized logic for these ADMS systems and the FLIZR operations are going to really be able to scale to thousands of feeders, models that contain millions of customers. And certainly, you're going to still have that local-based distribution automation teams and schemes to be able to augment that for your critical infrastructure and for your critical connections. But again, being able to deploy this system-wide to the remainder of your service territory, again, is really going to move this to the point where you're going to be able to restore the majority of your customers very quickly, and again, be able to really improve your reliability indices. The next piece about that, though, is to move this to more of a proactive type of scenario. What we've been talking about so far is really reactive. Taking this to the point of an analytics-based storm readiness, where We have all of this data within the utility companies. We have lots of historical data regarding storm-related outages, vegetation-related outages, things regarding floods, storm surge, snow and ice accumulation, and being able to take that historical data and put it into a data repository where the analytics can then look at that information combined with, let's say, weather data. Typically, we're looking at a 72-hour forward-looking weather window, being able to then run the analytics against that to determine, based on forecasted weather conditions, where we expect to have physical damage to the network infrastructure, what the extents of that damage is going to be, the assets that would be damaged, and then be able to start pre-staging crews and materials prior to the storm actually hitting. These analytics also employ a machine learning model so that the system is constantly refining the results of this analysis. And again, being able to take this to that next level so that we're able to start looking at these things actually before they occur and making sure that we're optimizing the resources that we have in both crews and material.
So John, you know, Hugh laid out a lot of avenues there, a lot of technologies that can help automate these processes and make it a lot more efficient. But you know, predictive analytics, distribution automation, a lot of these are reliant on quality data to function. So how can utilities ensure data quality while they're onboarding potentially, you know, many different systems, legacy systems, new systems from different vendors? How do you ensure quality data and efficiency in those processes as well?
It's a great question, and data quality is always important. I think those who've used computers for a long time are familiar with the garbage in, garbage out kind of concept, that if you have bad data coming in, then the best calculation system in the world isn't going to come up with good answers. And I think that's just as true, if not maybe more so, an issue with predictive analytics, because the outcomes are more uncertain depending on what kind of data that's coming in. And especially, as you said, Dylan, when you're bringing in data from a lot of different types of systems, the data quality issue can be a problem. You know, and Hugh alluded to this, when people are moving into machine learning or predictive analytics, there's typically kind of 3 steps to that. And this is part of the question of how you deal with data quality. So the first is, usually people will put these systems in place in a sort of passive test mode. The data is coming in and we're just watching it. The actual operators, users of the system, haven't even gotten a look at it yet. That's your kind of first place to start noticing data quality issues. So I don't think data quality has to be perfected before you start the journey of predictive analytics or even machine learning. I think you can do those things in parallel. So when you're in that passive test mode, you just start saying, okay, am I getting garbage out? If I'm getting garbage out, then let's go back and try to understand why the system recommended this silly thing to us, because it probably does go back to a data quality issue. And so you can use the predictive analytics system, not just to tune the system, but you can use it to tune your organization. The next phase that he mentioned is you move into sort of advisory mode, where the system's making recommendations to the human operators who still have full control. I think that's your next place to do fine tuning of data quality, to say, okay, now your expert operators, maybe that's plant operators or distribution system operators, they're starting to get this information. What do they think about it? Does it look like it makes sense? Does it help them make good decisions or not? And you still have that human backstop. Worst case, you're just providing, you know, not that useful information. The key at that stage, though, is we can't overestimate the quote unquote intelligence of the system. There's no magic box. I hesitate to use, I use the word machine learning a lot. I don't use the phrase AI a lot, because I think artificial general intelligence is still the stuff of science fiction. We can't, you know, we're not you know, giving away our decision-making process to the computer. So in that advisory mode, you know, keep your operators sharp and focused to say, if it tells you not to do something that you wouldn't normally do, then don't just do it blindly. Let's look at that situation. Now, that may sound kind of not optimistic. I mean, the good news is you can start right away. The question is then, how do you get to the ultimate stage, which is, truly automated or kind of autonomous decision making, where the predictions are coming out and the system is autonomously making that happen. That can be a very scary step for an organization. But if you take a step back and say, the automated systems we're using now have a model, and right now the model was designed by human programmers very far, maybe 18 months, 2 years, 5 years in advance of the circumstance that you're dealing with right now. Typically, these models are if-then, they're complicated, they're very deterministic. The promise of these systems is it gives you the chance to have the machine learn changes to that model in an adaptable way in real time as new information comes in, and that will help you become more resilient. The computer is still using a model that's ultimately shepherded by human beings. The question here is we're teaching a computer to update its own model in real time. So you can really get, once you've tuned that and dealt with your data quality questions, you can really get a system that has the potential to take autonomous action. We already see this in a lot of direct operational control systems. When we get an instruction to turn on, spinning hydro reserves, or, to roll a truck, as you mentioned, for automated distribution, outage management, it's definitely possible, but data quality is really the key. And like I said, you can kind of do it in parallel. I think using and making the most of that testing and advisory stage builds up the trust of the organization to when you start saying, okay, this thing's really primed for action.
Yeah, I just as an aside, I really like your framing of the terms of machine learning and AI. I always like to tell a story from a previous ETS. I apologize to whoever said it because I always forget who specifically said it, but they said Microsoft Excel can process 1 million cells. If you can process 1 million in one cells, you call it AI. And I think that's a good way of framing that sort of machine learning. Now, so Hugh, we've talked a lot about how there's technology available. There's smart business decisions that can be made. The organizational tools are there. So what are some of the biggest remaining roadblocks to the proactive automation we've been discussing? Are they largely financial issues, or logistical issues, or organizational issues? What's holding people back right now?
Well, I think that varies greatly from one company to another. Certainly, some companies can be constrained by budgetary considerations. My experience so far is that many companies are limited really more by the data quantity and the data quality and the penetration of distribution automation ready assets. And as we said, data is very important, not just the quantity of the data, but certainly the quality of the data. We don't want to use data just for data's sake. I think that the more information that you present to a user, as far as just raw data, it really becomes noise. It really becomes a distraction for a user that's trying to manage the system. What we really need to move to and where we're going with these analytics-based systems and distribution automation and autonomous systems is to really look at the data and present to the user actionable items. So don't flood me with all of the data that you have. Only show me the data that's going to make a difference, or the data that I can actually do something about to create a positive impact within the current situation. So, we talked about certainly, needing more data within the system, and that really moves to, getting visibility of the assets outside of the substation fence. The utilities that I talk to around the world, it's still kind of surprising to me how many companies still don't have SCADA visualization of SCADA information outside of the substation fence. I've talked to a lot of utilities that still have a lot of substations where there is no SCADA visibility even inside the fence. So there is an investment that certainly needs to be made as far as getting that real-time data into the back office in real time for systems like an ADMS to be able to look at, to be able to visualize, to be able to crunch those numbers, and be able to move to an autonomous type of system. As John was talking about, the data quality is certainly important. Again, historically, we've been dealing with OMS systems, which really just rely on a basic connectivity model. What is upstream? What is downstream? What are my isolation points, etc. When you start looking at these model-based systems where power flow needs to be able to run and be able to converge, you're really looking at very granular set of data that you need for these assets. We need to understand size, class, material. We need to understand phasing information, amp ratings. We need to be able to have an impedance model in order to accurately run power flow. Again, to make sure that we're going to operate the system in a safe fashion. We're going to operate the system in an optimized fashion. As well, when you start looking at the human side of this, workforce management systems have also come a long way, being able to look at the resources that are available as far as vehicles, being able to look at the different types of vehicles, the crew members that are involved or assigned to those specific vehicles, the skill sets of those particular crew members, even down to the point of being able to track the stock that is on each of these vehicles. Then being able to take the amount of work that needs to be performed, even if it's just day-to-day work or work that happens during these high volume events, and being able to take that work and crunch it against the resources that are available to optimize which crews are going to be working on which pieces of work in which sequence, so that we're getting the right crew with the right skill set, with the right materials to the right location at the right time. Doing things like reducing windshield time as far as crews having to drive back and forth to different locations. If we can optimize that, again, you're cutting time, you're cutting minutes, you're cutting hours out of these restoration processes. Certainly, as John said, we don't have to wait until all of that data is perfect. ADMS systems can be deployed today by almost every company out there. Again, to give them the benefit of that common SCADA OMS switching model, to have that single source of truth for their operational model. And then as they start filling in the gaps for the data that they currently have, being able to turn things over to an advisory mode, and then eventually to a full-blown closed loop autonomous system where any interruptions within the system are going to be detected, they're going to be isolated, service is going to be restored to customers. And again, many times within a minute or two. And then again, the second piece of that, being able to have that information flow post-storm. So all of that damage that has occurred physically to the infrastructure, being able to get that information into the back office, having that automatically correlated to the work that is within the ADMS system to do the restorations, so that we can start taking the damage to each of those locations and being able to optimize and prioritize which of those locations are going to need to be worked first, which ones we know are going to take hours to do the repair work, and again, making sure that we get the right people with the right materials out to those particular locations in an optimized fashion.
Thank you for that, Hugh. So we are going to get into some audience questions in just a second, but I just wanted to sort of bring this to kind of a head, encapsulate it. So John, bringing this all together, is it fair to say that the more we automate predictive and reactive processes for critical events, the easier it is to ensure reliability, resiliency, and worker safety? Is that framing accurate, do you think?
That is accurate. I think that you have to do these things well, right? So nothing, doing them badly is not going to move you ahead. But automation is when you are dealing with a situation where circumstances are changing much faster than ever before, and your model, your response matrix, the model that you're creating for what the organization is supposed to do has to be changed much more frequently and much faster than ever before, then the automation is the only answer. You know, if you've got to speed up that decision making, especially that sense making of new data, automation is the answer. I don't want to close without a little nod, and we'll go to the Q&A next, without a little nod to cybersecurity as well, because cybersecurity is both an opportunity for this and a potential downfall. If we are not able to secure these systems, then we will not get those benefits. On the positive side, the same tactics, the same techniques we've talked about, machine learning, adaptive models, can help you in cybersecurity, and they can help you become more adaptable there. We're deploying some of those things within cybersecurity to autonomously uncover, anomalous event models, things like that. So the same tools that can, be derailed without a good cybersecurity approach can help you become better at cyber, but we've got to keep our guard up on that. Otherwise, the benefits of these technologies will be taken away from us, in practice.
And John, that's completely right. Cybersecurity events, cybersecurity attacks as critical events themselves are, of course, worth a mention. If we had if we had another 45 minutes, would absolutely try and delve more into that. Maybe we'll definitely have to get some more content about critical cyber attacks, because that's definitely something that's happening more and more on a global scale. We're going to get into a couple of audience questions that we had come in a little quickly, because we're bumping up against time. But so Hugh, the first question we got was, what is the real difference between distribution automation that is being talked about in this panel and what we called smart grids years ago? What functionally is the difference there in the way we talk about it?
Well, I think smart grid is really a broader term. I would say that distribution automation is a part of the overall smart grid. Smart grid was a term early on that a lot of people tried to put in a box. Does that mean AMI? Does it mean distribution automation? Does it really talk about fully autonomous systems? Is it about analytics and being proactive with your response to changes within the system, whether that's outage response or whether it's just optimizing of the distribution network through volt-var control, through power quality and so forth. Smart grid really encompasses all of that. So the whole distribution automation and outage response is just a portion of the overall smart grid portfolio.
Thanks for that. And John, is there an opportunity for predictive signals to switch customers to behind the meter generation resources, such as rooftop solar or storage, before an outage on the distribution system occurs?
So great question. Now, I'll caveat this by saying at LCRA, we don't operate retail or distribution directly, but conceptually, as an industry person, when I look at your question, I think that's a very good, potential application of this. Now, it's more complicated because you're talking about how do you signal a customer to potentially tap into their own resources. One of our retail cooperatives, Bandera Electric Co-op, has actually done some really sophisticated work in that area to help provide visibility to the customer, to help them kind of make adaptive decisions like that. When do they switch to their own resources versus others? But that's a great point and a great way we can make the grid more resilient. A little more complicated to solve, but I think it's very much solvable.
Nice Bandera shout out there. Bill Hetherington,
customers, and Bill
really Hetherington, the CEO, was on my Solar Storage Fest panel. So it's
he's a sharp guy. He's one of the more innovative folks I've seen anywhere in the industry. We're glad to work with him.
Shout out, Bill. We love you. John, I want to thank you so much for being on this panel discussing critical event readiness with us today.
My pleasure. Thank you.
And Hugh, thanks for being here as well, laying out the case for distribution automation.
Thanks.
And I want to thank you all for attending ETS20 and participating in all of these discussions. And with that, I will hand it back to Aaron.